We thought we were through testing all the heat sinks, but apparently not, because we have a subscriber question that brought up 2 more heat sinks. So let's take a look. And this is from IMT 558 Deluxe. You've done a nice job over the past few weeks testing heat sinks for NVMe SSDs. Anyway, you forgot or not, would be good to test at least the thermal Grizzly heatsink and the EKWB heatsink for NVMe SSD. That's a great question. I'm glad you brought that up, and really it's relevant because of what we're going to be doing with thermal pads. Now, we did look at this, but we kind of set that aside, but we really shouldn't have, and that's going to be the first heatsink we're going to test right now. Therefore, the title of this video will be the Thermal Grizzly NVMe M.2 SSD Cooler. 2 thermal pads. It's black. It's an SSD M.2 NVMe heatsink. It's passive. That's important to know. And it's Thermal Grizzly, because that's one of the 2 pads we're going to be looking at. And this will be a one-time test, not a test to be repeated, and we'll look at the numbers in this and compare with the others. We have our 3 main components. We have the heatsink, we have the bracket underneath, and we have 2 thermal pads. And those thermal pads are none other than Grizzly thermal pads, which is pretty cool. Now, there's another thermal pad we're going to look at that has a better thermal conductivity rating, but for this to be included in the package, there's one other item in here that's a part of this on the bracket that we need to focus on. The wraparound bracket receives tension from clamps, those little clamp-on grips. There are no screws to create tension. And if anybody has any questions about the thermal pad, that's what's advertised. The Thermal Grizzly Thermal -8. Now, the technical stuff that's important to note, the Thermal Grizzly Minus pad has a thermal conductivity rating of 8 W/MK and a temperature range of -100 degrees centigrade to +250 degrees centigrade. Wow. Now, this whole issue about the thermal conductivity rating, I was going to wait and say that for when we did thermal pads. However, since we're on a Thermal Grizzly cooler with a Thermal Grizzly pad, it's now appropriate that we'll talk about that and continue to talk about it until we finally do the 2 thermal pads we're going to test. So 8/WMK, which is a big deal, but that W/MK, what does that mean? Okay, to reiterate, this is the description I have pulled from Digi-Key, and I'll put this up in the description. And Michael McGrath, who is a Digi-Key employee, has said, what is the specification for W/MK? All right. W/MK stands for watts per meter Kelvin. It's also known as the K value. The comparison of the thermal conductivity can be measured by the K value. The K value, or thermal conductivity, specifies the rate of heat transfer in any homogeneous material. If a material has a K value of 1, it means a 1 cube of material will transfer heat at a rate of 1 watt for every degree of temperature difference between opposite faces. The K value is expressed as 1 W/MK. The lower this value is, the less heat the material will transfer. This can be very helpful in selecting the thermal materials you might need when attaching a heatsink to a component, and is a specification filter to help narrow the options for thermal pads. Okay, that's a mouthful, but that's a good number, which means the higher the rating, the better the thermal conductivity to get that heat out of there. Now, another question came up from a subscriber that I want to share with you that plays into this. And this is from Echo the Fox. How come you only applied 1 pad? I'm curious because aren't the pads supposed to be on both sides of the SSD for better cooling, or am I just stupid laughing out loud? Echo the Fox, that's a great question. I'm hearing you. I understand where you're coming from, but you have to understand also what we're laying this out for as we go through all these. Let me show you overhead. Now, I'll get into the specs on the test system, but we're looking at 3 places we're possibly putting a heat sink. 1 would be on a dual M.2 NVMe card, which is what we'll use to test. 2 would be on a quad card that does not have its own heat sink. Number 3 would be on a motherboard. Okay, there's a motherboard heat sink right here. In fact, this motherboard has 1, 2, 3, and 4. There's actually 4 M.2 drives that can be put on this motherboard. These 2 each have an individual heat sink, but these 2 over here have 1 heat sink. The reason being, have you ever seen a motherboard heat sink that has a thermal pad underneath the M.2 card? Well, neither have we. So of the 3 places we're possibly looking at putting a heat sink, again, number 1, 2, and 3, the third one being on the motherboard, the possibility exists, and because of the differences in some of these, we wanted to keep it as simple and as apples and apples as we could. Okay, some of the heat sinks allowed for dual thermal pads. Some of them did not. In fact, we had one, if I remember correctly, that had 3 thermal pads, and that was the one that had the pipes. That was the one that had the 3 pipes from Sabrent. Then we had the one that had the 4 pipes, and that was the Acidity, and that was phenomenal. And that had 2 thermal pads. Okay, because several of them have 1 thermal pad, because what goes on the motherboard would be 1 thermal pad, we did all of our testing with 1 thermal pad, except for those, as near as I can remember, 2, possibly 3 exceptions. But in this case, for this one we were getting ready to test, since it is from Thermal Grizzly and they supplied 2 pads, a thin one for the bottom, a thick one for the top, that takes into account for something else you have to think about. Okay, we're going to have a clamp that's going to grasp that. It's a compression, but it's a predefined fit. There's no way to adjust it. And the issue with that was when you have a pad and a pad, different thicknesses, but how thick is the memory? Is it single-sided or is it double-sided? The memory we're looking at is single-sided. However, as we have stated, with some of them, there may be an issue if you've got double-sided memory, and that's the reason for the 2 thermal pads underneath the heatsink from Sabrent, because it had a lip where that screw fits, and because of that lip where that sits, you had to have 2 thermal pads to get that up. Now, if we had double-sided memory, that would take up the space of one of those pads underneath. So that's why we're doing this the way we are. Great question. Glad you asked. You guys are incredible. I love my subscribers. And by the way, this is Builder By. My name is Gil Boyd. I want to thank you for joining us. Now, since this is going to be a one-time test, we know for a fact of what we're dealing with on the thermal pad, which is a rating of 8W over MK. Cool. One other pad, actually 2 I found, one that had a rating of 12, I believe it was 12.8, and I found another thermal pad that had a rating of 13. All of them have to be trimmed. So the nice thing about this, we get what we need in the kit. We're going to do an unboxing, and as always, it's going to be, we'll cover those 4 things. We'll do a unboxing, examination, installation, inspection, and the test, and we'll put the 2 applications up so we look at and get our results. Now, the numbers we're looking at, what we want to compare with the heatsink that's on the motherboard, we were able to achieve 65 degrees. And the testing we're going to do is going to be on the Supermicro dual M.2 NVMe adapter. And on that adapter, the drive we're going to test is the primary drive, primary position, meaning the WD Black SN850. And that's going to be sitting in an 8-lane slot, the first 8-lane slot on this motherboard. And I'll outline the system in a minute. Now, the second drive on here is a Samsung 980 Pro. Both of these are single-sided memory. And another question that was asked was about testing and comparing these, and I'm glad somebody asked and pointed that out, because there will be another video where we talk about not just the test we do, which is burst mode, remember that, but an actual throughput where we'll take data and go from one drive to the other and then compare. Take drive A, copy data to drive B, take drive B, copy the data back, but not the same file, so they're not in the cache. And then we'll compare and see what kind of results we get. And if possible, try to see not only what the throughput's going to be, because all the specs we look at are all about burst mode. But after you look past the nature of burst mode, and it gets really relevant when you're talking about something like Thunderbolt 3, Thunderbolt 4, once we get past burst mode, what we want to know is what's the actual throughput. And this was one of those things that kind of reared its head when we started getting into SATA 3. We went from SATA 3 on a spinning drive to SATA 3 on an SSD. Wow. And now we're talking NVMe, and of course these are 2nd generation drives, PCI Express 4.0, and on the horizon we've got PCI Express 5 coming out, which will be 15,000 megabytes. So these are 7,000 megabytes. Faster they get, the hotter they get. And yes, we've already seen there's one company that's come out with a cooler for an M.2 NVMe drive. There's some wicked stuff going on. It's just a matter of time. And if I can find the information, I'll get a link up in the description so I can share that with you. But if one of you guys see it first, thanks for sharing it. Okay, while we're at it, we might as well go ahead and go over the platform, and then we'll get this out and go through our 4 items. This is the Gigabyte TRX40 Designare, which we think is the best value for the money because we have 2 16-lane slots and we have 2 8-lane slots. And to reiterate how this is set up, we have the secondary slot with an EVGA GeForce RTX 2080 Ti, and in the primary slot we have a 4-drive quad card. And in the second 8-lane slot, of which we're only using 4 lanes, and remember we lose 4 lanes because of this being dedicated resources, we can only allocate PCI Express resources within a slot. We cannot allocate PCI Express resources to another device. Motherboards like that share resources means something is on and something is off. So to understand that Thunderbolt card, for the price of Thunderbolt, with motherboard support, we use 4 lanes, we lose 4 lanes, which is kind of a bummer until something else happens. Hello USB 4, I'm just saying. So we're going to look at this drive on this particular card, which is the Supermicro Dual M.2 NVMe adapter. Oh, and I almost forgot. The question comes up about the humidity and the temperature. Right now we are 47% humidity and the temperature is at 82 degrees Fahrenheit. So you'll have to extrapolate Fahrenheit to centigrade. That question has come up, so we've addressed it. There's only one heatsink we've been asked to look at because it was not appropriate to test that particular heatsink on a dual M.2 NVMe adapter or on a quad adapter. Even on a motherboard, that thing was huge. It was an active cooler. Kind of wicked. I'd kind of like to know the numbers, but it was not appropriate where we started when we went down this rabbit hole. And it all started with dual M.2 NVMe adapters that don't have heatsinks that should. And the question was asked, what about heatsinks? So down the rabbit hole and in the weeds we go. Pretty simple packaging, probably the simplest I've seen yet. A blister card pack. We have a staple on the top, and this is labeled as the Thermal Grizzly NVMe M.2 2280 SSD drive. Written in multiple languages, and while we have it on the table, I expect there's going to be some instructions, but I'll read what's here on the back while we've got it where we can see it. Optimized heatsink for best passive cooling. 2 pieces, a minus pad, 8-inch high-performance thermal pads included. I think what that means is the minus pad 8 high-performance thermal pads. There's 2. There's one that goes underneath, which is 0.5, and the one on top, which is 1.0. We'll get to that. Optimal SSD protection with fully enclosed design. Easy install due to 2-part construction. That's what we're going to find out. Now, depending on the results, we're going to see how this compares. And the big advantage of this, it's already got the Grizzly pads in the pack, which I'm excited to see how this is going to work out. And no, I would not have tested this because we were going to test the pads, but hey, you guys ask. That's our goal. Okay, here's the instructions. Number 1, we have the bottom bracket with a 0.5 millimeter pad. Number 2, we put the SSD on top. We'll watch our alignment and check as we always do. Number 3, we put a 1 millimeter pad on top. Number 4, we then clamp the heatsink in. And then number 5, we install it. So let's take a look at the instructions, which is pretty simple. Remove protective films from the thinner thermal pad and place it in the housing, as we've discussed. Place the M.2 NVMe SSD in the housing, which we will do. Remove the protective film from the thicker thermal pad. Place it on top of the M.2 NVMe SSD. And the number 4, slide the heatsink into the housing and fix it on the other side with slight pressure. So we will get some compression. How much? We're going to see. But remember, we're using single-sided memory. The SSD cooler is ready for assembly. Sounds great. Let's see what else we got in the box. A minus pad. Nice. Another minus pad. Nice. Easy to tell which one's the thick one and which one's the thin one. The one on my left hand is the thick one. The one on my right hand is the thin one. So I'll lay them out at the top accordingly. Bottom, top. And now the piece de resistance, the 2 key parts. And very simple, very clean. I don't see this as a replacement on a motherboard because the clamps, the way they stick up. In other words, when you put this on the motherboard and then you've got some kind of I/O card above it, because of those clamps, the way they clamp on, I think they would interfere or be in the way of any kind of I/O card on top of that. So if I have the clearance and I'm not worried about something on top of an I/O card, then I've got space to go with stuff. Now, can I use this on a dual card? Absolutely. Can I use this on a quad card? Absolutely. This is thin, this is lightweight, and this may be the solution to a problem. It's not as thick as I'd like. There's only one material here. It's aluminum. It's anodized. So I'm going to be curious to see how well this all goes together. So we'll start with the bottom for the thinner pad. Make it real easy to peel. And I'll start from this end because that's the notch that's going to be crucial. So I have a blue pad on the bottom that I peel that film off. Then I have a clear film that I'll peel from the top. Nice and easy. And of course I overlap one end, so we have to remember where the gap is at right here will also be where the gap is at right here. So those two line up. I want to make sure we have our orientation correct. There's a film of dirt on here, or dust I should say, so I'll use my gloves, the back of the gloves, to wipe that off. Nice and clean. Let's take a look at the card. I'll tell you, the more we use this Supermicro card, the more impressed I am with it. For a server component, I had no idea we'd be using it this much. Okay, set that aside for a minute. I'm going to dry fit this because I want to see how this is going to work. So I need to slide that in. And no, I have not taken the film off. I'm doing a dry assembly. Because of those clips, I want to see how this needs to work. And my alignment, let's come in on that a little bit. On the right side, I'm looking at this alignment here for the notch. And on the left side, I'm looking at my alignment for this notch. And I'm going to roll this over and see how well we clear. Oh, we clear by a lot. You can kind of see there with the reflection. We're really good here. Okay, that was my concern. So if I line this up and push this back so this lines up here, this lines up here, and I've got probably 32nd of an inch sticking out at that notch. I like that. So this on the left will be my alignment point, where I'll put that at 0. Good to know. I don't like surprises. So the most difficult surprise is going to be sliding that in without letting that stick down. Unless, yeah, I'm a little concerned about the, so I'll hold that above the heatsink when I slide that in, very gingerly. Okay, let's peel. And I can tell here on the back side, there's a little bit of that thermal pad sticking out, so I can get hold of the clear edge, and I should be able to peel that without stretching. Using a micro screwdriver and keeping that close. I'm peeling that straight back. Got a little bit of a wrinkle. I'm good. Now I'm going to slide the memory in, and I will keep it above the heatsink until I'm ready to set it down. Lined up on the left. Now I'll let it drop into place. Clearance looks good. Okay, so much for that. And as always, I will be sure and save my protective covers for the thermal pads. And yes, thermal pads are supposed to be used one time. Like the way they package those, nice. Okay, so we got the first part done. Assembly on this goes pretty quick. So that was the 0.5 millimeter. Now we'll take the 1 millimeter pad that goes on top. Again, single-sided memory. And I am going to apply this to the drive. Lengthwise on the left, that looks good. Lengthwise on the right, looks a little short. So if the cooler is what I want to keep the coolest, I will start on the right end, line that up, and then we'll see where this comes out on the left end. We'll blue pad first, peel that off, save it, drop that down on the controller, line that up, and let's see if we can grab the edge with a micro screwdriver and gingerly peel that back. Done. Okay, we're fully covered at the controller. We got a little bit exposure here on the memory, as if the pad could have been a little bit longer, but I'm sure they made it that way for a reason. All the other pads we've worked with on all the other coolers had them all covered, and we even had one that stretched out a little bit because of the way I was doing it. Okay, now the key element, let's get this little heat sink on top of there. See what we got. I do think we've assembled this the fastest of any of the ones we've worked with. Watching where our notch is here and here. So we'll put this in as they talk about it, one side, and then we will clamp that down. So I'm going one edge down so I get that equal pressure on there, and that'll be our compression with those two rings. Or I shouldn't say rings, with those clamps on the edge. So I've got this edge down, and I'm going to push the front edge down, and I'll tilt this up so you can see it as I do it, and snap. Now, how good is the compression? Well, could be better. Would this be appropriate for double-sided memory? Maybe, but I don't think so. So we have two thermal pads in here. We got our notch lined up, so we're good to go on both sides. And you get an idea of the thickness of the device. Too thick to go on a motherboard if something's above it, but lightweight enough that it'll work in any of the places that we're talking about. So somewhere between 65 degrees, and which was the motherboard heatsink, and 92 degrees was on the Supermicro card without a heatsink. So let's get this mounted, get it installed, and we'll test. I do know one thing about doing this. Whatever kind of preconceived ideas we may have or had, throw them out the window. Because I've really been surprised, fascinated, and amazed at the results. So every time I get a chance to test another one, I'm stoked. Okay, on the right side, notch is good. On the left side, we lined it up. We're good to go. We managed to clear the escutcheon, And the wraparound on that fits really nice. I think that's the tightest wraparound I've seen, clearing that component on the I/O card. Next step, in the box we go. I gotta say, while we're doing this at this point, this compression fit, which is a couple of press fit clamps, the next one we're going to look at is by EK Water Blocks, and it also has a compression fit like that. So these two are different than all the others, even though both of these are passive cooling. And I'm really curious to see how this one performs and how the next one performs. I mean, after all, EK Water Blocks, you know, what can you say? We're going in the first 8-lane slot, and remember, this is a slot as it's measured and defined on the motherboard. As it's defined according to the case, we're in the middle because we have on the left side a blank I/O panel and on the right side a blank I/O panel. Because another option we've considered, thought about, and some of you have even mentioned, what about using fans? And you know, that's an option. I got to tell you, this is my favorite right now based on weight. This will work anywhere. A dual card, a quad card, a 5-drive card, a 6-drive card. I'm just saying, we've still got lots of stuff to test. We'll get there. But I'm saving it kind of close to the vest. We got to do this stuff before we can get to the other stuff. Cards installed, secured, ready for the next step. So we're going to plug this in, turn this on, and power up. Now, once I energize, the things we'll be looking at on the motherboard, 3 things. 1, we'll see power to the video card. Number 2, up here we'll be able to see the readout on the LEDs for the BIOS codes. Don't want to say error codes, but BIOS codes. Up here, number 3, we have a PC speaker you can barely see. I like to hear that post, that power on self-test, because that tells me once we hit post, then we're good to go the rest of the steps. If I don't get post, then I'm looking over here at the error codes, the BIOS codes, trying to figure out who's on first. And we're dealing with some of that as we have with the TRX 40, but with the WRX 80. So some of you that are working with the WRX 80, there's some issues we're dealing with which have to do with device enumeration that we're trying to work through. Apparently we've found a problem with the Gigabyte board I want to tell you about, but there may be a problem on some of the Asus boards that it will work, but we're trying to figure out what it is that makes it work. But I'll just say BIOS error code 94. We're working on it. So we'll turn on, let's energize. Power up, video card has lights, BIOS codes have lights. We're waiting on the beep code. We have post. As soon as we get it up, we don't need to check anything in the BIOS. We're going to go straight to the operating system, put our 2 applications up. We can check heat, run our speed test, see what we've got. I'm excited. And for those curious, we are booting off of a drive on the motherboard on the primary connector to the CPU. On this particular motherboard, we have 2 M.2 NVMe connectors to the CPU, and the other 2 are through the chipset, which are slower. So when we start doing the testing, we want to stay on the dual M.2 adapter unless we get into more drives. It's either going to have to be to the CPU on the motherboard, 2 slots, or it has to be in one of the PCI Express slots. Also, those are to the CPU. So that's the hierarchy of 1, 2, and then 3 through the chipset as we test speeds. We want to try to keep it apples and apples. So the first thing we're going to do is bring up hardware info 64. We're only going to run sensors, and because we do not have the hybrid BIOS RAID enabled, we are able to see drive telemetry. Okay, we're looking at smart telemetry on the drive we're going to test, which is the WD Black SN850. We're looking at current, minimum, maximum, and average. We can also see the temperature on the adjacent drive right next to it, right below it, on the same Supermicro card, which is the Samsung 980 Pro. And we'll see the same temperatures, current, minimum, maximum, and average. I'm going to highlight, and we're going to go run Crystal Disk Mark. We know the drive we're looking at, which is drive D, 1 terabyte drive. So we have a 1 gigabyte test file to clear the cache. We're going to do all. And at the end of this, what we're going to do is confirm 3 things. 1 with the test, which is a burst mode test. We're going to be looking at the speed of the drives. We're going to be looking at the speed of the drives on the card. Because remember, the drive is PCI Express 4.0 second generation, so we're going to get 7,000 megabytes. Number 2, the card is spec'd at PCI Express 3, but you see the speed that we get. And the number 3, on the left-hand side, we're watching these temperatures. We started out at 36 degrees, and right now our current is 52. And the parameters we're looking at, if this were on the motherboard with a motherboard heatsink, which would have only 1 thermal pad, 65 degrees. But on the M.2 dual card, which is the Supermicro without anything on it, the WD Black SN850, 92 degrees. So parameters. What I'm curious about, and again, the numbers we get on the read are spot on. The numbers we get on the write when we get to the second set of numbers on the writes per megabyte, that's where we get the maximum amount of heat. And once we achieve that number, then we'll know what we're looking at. The question is, how close will we be to 65 degrees? And remember, we're using Grizzly thermal pads with a value of 8 W over MK. And for those wondering, as I've commented before about the MOSFET fan, I can hear that MOSFET fan on the motherboard whining every once in a while. It sounds like one of two things, either a coil whine or wind blowing through an old door. 62, holding pretty good. We don't know yet until we hit that second set of numbers on the writes per megabyte. Anybody want to make any predictions, any guesses? I think the real key to that heatsink is going to be those thermal pads, but we'll see. And of the drives that we have tested that we will retest them with thermal Grizzly pads first, and then a second set of pads, and see what we can do to improve those results. Now the question always being, do I need a heatsink for an M.2 NVMe drive? The faster we go, the harder we go, the greater the requirement to keep the heat down to prevent throttling. On PCI Express 3, it's not as big a deal, but I would still do it. Okay, 67 degrees. 68 degrees. Wow. And on the motherboard heatsink, which has a thermal pad and aluminum, we got 65. And this is at 68. And our best was with the heat pipes. The acidity got 48 degrees as a reminder, and the Sabrent was at 54 degrees. What I'll do when this is over with, I'll throw that chart up just as a reminder. 68 degrees. Well, not until it stops. Okay, test is complete, and we held out at 68 degrees. Let's take a quick look at the chart and see how those numbers fit in. Okay, there's the results of the chart. The WD Black SN850 at 92 degrees. Number 4, the Sabrent Rocket 3 heat pipe, 54 degrees. Number 8, the Acidity 4 pipe at 48 degrees. And the number that I don't have up here is just on the motherboard, to reiterate that for a third time, which was at 65 degrees. So here we're looking at this device at 68 degrees, and on the motherboard we had 65. My advice, based on the numbers, stick with what comes on the motherboard. That's kind of an easy deal. But if you have the space and you can do the heat pipes, I got to say the Acidity was topped out at the best with 4 pipes. It's all about results. So I didn't really know what to expect with this. I kind of expected better, but you know, it is what it is. So as always, we did the test. I want to thank you guys for watching. This is Builder Buy. Next video, we've got one more to do, which is the AKWB, and then I hope, unless somebody else asks another question about, well, what about this one, then I hope we're going to be looking at 2 different thermal pads. So I want to thank you for watching. This is Builder Buy. My name is Gil Boyd. On to the next video. We're out.